today, but that's okay. Okay, yeah, I mean, mainly today I think it's mainly an update. I can give a quick run through, but I think if you want, you can dive a bit more into detail. So I think the progress is that, I mean, we've had like 7 contributors. I think we've raised around, or we had like 5 PRs. Not all of them. Oh, you merged one already? Keneal, he's working in Polygon, but he's also, yeah. Yeah, so he's not here, he has a meeting, so he can't make it. Yeah, I mean, yeah, I don't know if he's here as a builder, to be honest, or as a mentor, but like he's also helping to build. But yeah, you can reach out to him. But he communicated with me that he's not going to be able to make it. So at least I knew about it. Yeah, anyway, so we've had 6 PRs, and I think from 6 people. I think the only one who hasn't raised PR yet is Kiba. I actually don't know if Kiba. Oh, he's not there. Okay, great. Good to know. Live updates. Yeah, but okay. Anyways, so yeah, so everyone has at least created a PR, which different kind of exercises. I think if we look at all these PRs, we see, I mean, what I was working on with Harold as well. You can also come if you want to. It's mainly on like the finite fields. We started initially with like some group theory exercises, which I can also show very briefly. Sorry. Yeah, so basically the whole idea was for us that to give a better intuition on the different kind of group axioms, just like leading on to finite fields, basically giving different kind of examples for these different axioms, and in the end basically having a way, I think this exercise, that where students are supposed to like basically provide a proof for different kind of sets and the multiply operation to essentially ensure all these different group axioms. It's a work in progress still, but everything works as it should, but I think there could be a bit of a more intuitive way to maybe teach these different kind of concepts. But yeah, so that's basically for the group theory related exercises, and then Harold will also be working on the finite field stuff. Do you want to say something about that?
Yeah, actually, I write the exercise in the Python prototype. I trying to implement the algebra structure in the Rust, but I found this really difficult. Yeah, it's like writing the axiom into a tree is quite a challenge.
Yeah, I think we can figure something out. But yeah, so that's basically for the final fields, and I think for me the goal next week would be to hopefully move on to maybe working also experimenting a bit more with Plonky 3 and see how we can integrate it, if that makes sense. But I haven't looked into it too much yet. But yeah, that's basically from my side. And who wants to go next? Yeah, sure.
Okay,
Do you
so
want to share screen, or do
yeah,
want
you,
to
you
open?
can directly open the pull request. Yeah, so I'm basically working on the split and fold, which is basically the heavy part of the IPA, bullet proof that Dr. Guo gave us a session, and you can check out. The thing I want to mention is there is a very tricky part of the inverse module linkage multiply, and yeah, and you need to figure out that out is very interesting. You need to do something like the Fermat's little theorem to prove that. Yeah, so it's interesting practice, and I also do the same part on the Python in another repo. You can check it out too. Yeah, I will keep follow the doctor's Guo's talk.
Do you want to show something specific here?
Like I just raised the PR for the Schnorr protocol. Yeah, so yeah, like this is the code for the Schnorr protocol. So like we create a struct with the prime, the generator, private key, public key. I've explained how it works in the README file, and then the user who wants to like learn about Schnorr, he will have to write the commitment function, then the response function, and the verification function. Like I have mentioned what he will have to create, and also how it works in the README. So he just have to write it in Rust, and that should work. Yeah, and I'll add the Peterson later. Okay.
And you must one here.
Yeah.
Yeah, so I think I can also briefly cover from Keneal's side, if I find it. I mean, I think I also have it open here or no, here. Yeah. So okay, so I think Keneal was basically working on Plonky 3, and to basically make. Okay, let me see. I also just looked at this. To basically just generate proof and verify it for the Fibonacci sequence. Here, basically, he just constructs AR and the trace. They're kind of separate, and then in the end, he also runs the verify function. I think the only issue basically here, there's not really an exercise. It's just kind of like a Rust program. But so I'm gonna talk with him, and we're gonna figure out how we can turn that into an exercise. And I think this is just an example of applying Plonky 3, but I think, yeah, again, like I think we just have to figure out how to best separate these and maybe modularize it so we can actually turn this into something that students, people can learn from. But yeah, I think that's mainly going to be starting next week when we work on that. But that was his update. Then Beer, I think Beer is going to come back. Yeah? Okay, good. Okay, good. So I think yeah, I mean, I haven't really looked too much on his side, but it's basically,
I will say
yeah,
it did like some improvements on the
right.
compilation. He still has some things to change on the PR,
Hmm.
but it's basically done. He also fixed an issue there was
With the next.
with the watch, the
Yeah,
watcher
right.
for the file.
Yeah, good. Yeah,
That's it.
cool. Yeah, so things back, we can also line on that a little bit more. I also see, yeah, okay. There was one thing more that I forgot just now, but anything else you want to say about? Oh yeah, right. So the goal would be then also to maybe make it easier on root, that we maybe have more maintainers, so we can also like merge and review. Depends. So we need some kind of new structure, I think, right? So we can make it a bit more fluent. But I think that's something we can focus on next week as well.
Yes.
Cool.
So I think Block 3 has two front ends, no? Like the air and another one, no? Or just is the air? There is also the air.
The Block 3 on the air for now, but I think
Okay.
we can integrate classes.
Yeah, I mean, yeah. So.
No, yes, because I was going to ask you if the sample was using air.
Oh, okay.
There is only one there.
I mean, optimally, I would like, because I mean, I would like the exercises to explore the toolkit that Plonky 3 is a little bit more, rather than just finding end to end all the time. I think that would be so much cooler.
And also because it's the same logic that is on Circle.
Okay.
That's the split logic
Mm.
for the program.
And you're going to apply this, you can apply for the, because there is $100,000 that.
Yeah, we did apply already. Yeah.
Yes, you're going to apply with this project. Okay.
Yes, I mean, the deadline was like 2 weeks ago, so we applied with it.
Okay.
And yeah, I don't think any results came out yet, but there are also some other educational focused projects, but I think still, I mean, no matter what, I think still we're going to continue doing this anyways.
Yes.
But I think also the Nethermind sponsors also have an educational section.
Yes.
So Nethermind, Polygon are the two sponsors that we basically focus on with this project.
Yeah. Okay.
Yeah.
So Netherman is giving a prize also?
Well, I don't know if they give a prize, but I mean, because the whole idea was to focus on projects from sponsors, and Nethermind has also a section for education.
Okay.
That's the whole idea. But I mean, yeah.
Yes. No, yes, you can submit that, like, for them to put it up there, no, the Netherman stuff.
I haven't really talked to him about this, to be honest, specifically. Yeah. But yeah. Cool. Any other questions? Okay, all right, thank you.
ZkAuction is already here or no? Okay. Yeah, sure.
Okay, hello everyone. So I will talk about our project and what we have done in this week. So first, I want to show the goals and the quick review to our architecture. So yeah, so our project is try to use ZKB to choose a high bidder without revealing individual bid amounts, and yeah, it ensures both privacy and fairness in the bidding phase. And we want our project will serve as a reference model to developer in the future that want to build the apps with Plonky 3 and ZKP. So here is architecture of our project. There are four main phases. And the first phase is initial phase, and so at this phase, the owner of the asset will generate the pair of private key and public key, and will call the create option in the function in the smart contract. Some parameters that the owner need to fill in this function is like the public key, the deposit price here, and also the duration of the bidding process. So next, in the bidding phase, anyone who want to join the auction can uh, use a public key from the owner and encrypt then money. So and then they will send the encrypted information and deposit into the smart contract. Next is in the opening phase. Now the owner can um, now the owner send the private key into the proving service, and then the proving service will get all the encrypted bits from the smart contract, and then use the private key from the owner to decrypt them into the plain text, and then the proving service will compute the winner. Then it also generates a proof to prove that the whole process here run correctly. And then after that, the approving service will send back the winner and the proof into to the owner. So the owner now can submit the winner with the corresponding proof into the smart contract. And then final phase is that the smart contract after receive the proof, and the winner will it will verify the proof, and if the proof is valid, the smart contract will finalize the auction, and now the owner and the bidder can claim the asset and the money from the smart contract. So that is the basic flow. And what we have done in this week is that we use SP1, which is the ZK virtual machine that can generate the proof to any Rust program. So we used SP1 to deploy the proving service, and we use ECIES elliptical integrated encryption scheme over the SECP256K1 curve, and use KeyCard 256. And here is for the proving service, and for the smart contract we also created the first version of our smart contract, and it includes some basic functions. So before showing the code, I want to talk about how can we verify the proof that generated by the SP1. So actually, we use the Allied network. Allied is a decentralized network that can verify any the zero knowledge proof from the SP1 and post the result into the Ethereum blockchain. So basically, what we do here is that we send the proof into the patcher here, and the patcher will patch many proofs into one data and send that into the data service. So now any node in the Allied network here, we call the verifier, can get the data from data service and verify that. And then they will post the result with signed by then key into the POS signature aggregator. And then if the two-thirds nodes here have the same result, that result will be sent into Ethereum blockchain. So now, so any user can see the result here. Yeah, so I want to show you the code that we have. Here is here is the proving service that we have done this week, and yeah, and also we use elliptic curve for encrypt and decrypt. Yeah, so and the smart contract includes some basic function like create option, yeah, and finalize option, something like that. Actually, we want to show the demo for you, but we have some problems like the proofing service that we create. It works very slow. It takes about 6 minutes for generating the proof with with about around 10 bidders, and the proof size is also very big, about like 21 megabytes. So I think that we need to make it faster and make the proof size smaller. Yeah, so it is the first approach that we work in our project, but we want to make our project also be a reference model for any developer in the future that want to make the apps with Plonky tree. But if we have another version of our project that we don't use SB1 for this version, but we use Plonky tree directly. So here is what we need to do if we work with Plonky tree. We need, because Plonky tree now support Stark, so we need to define our error constraints and the execution trace. However, Plonky tree now only supports some small fields in the constraints, and the operation in the execution tray are very limited with some basic addition, subtraction, and multiplication. So that if we want to create the execution tray and the constraints for elliptic curve and kickback hash function is quite difficult and complex. So we decided to create a simple version of this, that we use the encrypt and decrypt algorithm is RSA about 32-bit, and here is the execution tray that we generated with this algorithm, about 20 columns. So I will show you the code that we make in this. Here we use Plonky tree, and here is a FI config with the block factor is 3, and the number of queries is 80. So here so here is our code that generates the execution trace. Yeah. And yeah, and here we config also the error constraint. Here is all the constraints for the encrypt and decrypt function. So basically, we will demo with the encrypt and decrypt function with about 100 bidders. Here is one. So here we for generate the proof our 100 bidders. It took about 9 seconds, and verify that is very quick. So it's just 200 milliseconds. So yeah, so that is all things that we have done in this week. So thank you. Yeah, so you.
I think one of your slides has like private key going over the wire.
Yeah. Yeah. This one, right?
Yeah.
Yeah. So actually now the proving service the owner can have his own proving service program. So he just.
So it's local.
Yes, local. Yeah.
Have you identified the bottleneck in proven circuits? Like, so you say SP1 takes 6 minutes. What's the hard part?
Yeah, actually, because SP1 is the general virtual machine, so I think that we need to improve. I think our logic to insert in our proving service. So yeah, so that's it we need to do in next week.
Okay, gotcha. But maybe like, is it like cryptography, hashing,
Yeah.
signatures?
Yeah.
What takes? Have you like kind of traced it? What part takes the longest?
The part take the most time is the decryption. The decryption.
So
Yeah.
verifiable encryption.
Yeah. So any question?
I think that because we are using like not ZK friendly algorithm, so that's why it takes longer than if we are using some ZK friendly ones. So that's what we will need to investigate in the next week.
Yeah.
Yeah.
I think LGML is usually like the fastest in circuits. Like if you work with like baby Juju,
Yeah.
you will work with results, at least in the curve-based nerds for maybe like 43. I will look at Pluto. GitHub organization, they have like IAS ciphertext circuit.
Yeah, yeah, but like we have two different versions, and one of them is just using like SV1 as the execution environment. So I think I will have to look at the underlying of the SV1, so that I can like have a
Maybe you
deeper.
can use some precompiles.
Sorry.
Maybe you can use some precompiles.
Yeah.
Like say implement LGML over VM curve.
Okay,
Okay.
okay, thank you.
So any question?
One more question, please.
Yeah.
As you mentioned, like right now, when you generate the proof, it will cost like several minutes.
Yeah.
So that's the thing you focus next week.
Yeah.
Oh, okay.
You have to optimize the code. Yeah, thank you.
Yeah. Thank you.
All right. Hello, morning. My name is Jeff. I think I'm one of the very few people in this room who doesn't really get ZK, so this will be a change. I'm focusing more on developing public good services for DeFi projects. And HaaS hooks and Zindicator are two different things. Go over them very quickly. So HaaS hook, hook as a service. It's a public good hook for Uniswap v4. Enables multiple ad hoc and user specified hooks as an extension. How many people are familiar with Uniswap v4? All right, Uniswap v4. Okay, great. So, or Uniswap in general, like or DEX, AMX, constant product. Okay, good. So really quickly, one of the key innovation in v4 is introduction of hooks, which is just like a callback to external functions. So instead of doing a entire swap function within the Uniswap contract, this is Uniswap, this is hooks functions, it allows at certain key points of the workflow to call external contracts that can execute additional logic. So before swap, there's a hook. There's a hook for after swap. There's a hooks for before adding and removing liquidity, and after adding, removing liquidity, before, after donation, before, after initialization. Just a lot of key places where external logic can be executed. And the hooks has to be specified during initialization process. So pool key is what identifies a Uniswap pool. And iHooks is the external contract that will be called during these callbacks. That means, unfortunately, there can be only one hook per pool, and the logic is forever coupled together. So why is this a problem? Now let's say I'm a developer, I develop Uniswap v4. So that means as a developer who creates hooks and execute external logic, the developer will be responsible for also attracting liquidity and volume to this specific pool. Otherwise, the hooks function will not be executed and there's no business benefit can be generated. And as someone, let's say, for example, a token issuer who are more on the business side of things that wants to incentivize liquidity or do something to the volumes or liquidity or volume, they have to, first of all, look for a pool that has the token pair they want to incentivize or somewhat otherwise interact, and then they have to somehow insert their own action into that temporarily or otherwise, or they need to really spin up a new pool to incentivize volume and liquidity in order to make their business endeavor to be able to carry out. And also as a user, obviously you want to do your actions on the most liquid pools, but that pool may not also always have the hooks that you want. So that is also a dilemma. The root cause is that there is a one-to-one hard coupling between the pool and hooks, and this is created at creation time and cannot be changed afterward. So hook as a service is a very simple concept. It's just like, instead of, I'll create a hook, I'll generate pools using this hook, but my hook doesn't do any logic except call more hooks, subscriber hooks. So this is more like a provider hook. These are subscribers that they can subscribe themselves to or unsubscribe at any time. So what that does is it enables, first of all, multiple external executions. They can be ad hoc. They can attach or detach themselves at any time. And the user can also, through a hook data argument, to pass additional hooks that they specify to execute. So this will decouple the logic from the liquidity and the volume of a pool, and that's more flexibility. I was gonna show a little bit of a code walkthrough, but okay, so this is good, better. So provider hook is very straightforward. It just provides some, let's look at the interface first, maybe. it provides a function to subscribe and unsubscribe, and you can subscribe either to specific pool or globally. If you subscribe to global, that just means passing a empty pool key. Then your contract will be executed, your hooks will be executed on any pool, all of pool, always. And you notice also there's a gas rebate BPS. Obviously, when external your contract being called, you're spending users, message senders gas. So you had to rebate them for the gas you spent. And this is I also use this as a kind of auction for the order of execution for the hooks. So if you want to guarantee that your logic being executed, you had to provide a bigger number here. This is always above 10,000 in basis points. And from there, it's pretty straightforward. Implement all the so deposit and withdrawal are to do with the retainer. You have to deposit gas to the provider, and that will be depleted as external logic, your logic is being executed. And these are the Uniswap hooks. They'll just call subscribers and rebate gas. And that will be just this big ugly thing, needs refactor and translating into assembly. But basically, it just loop through in the order of gas rebate specified and executed from both global and pool specific. Yeah, so that's the gist of it. The code is about, let's say, 70% complete, not counting unit tests. And then there are a bunch of limitations and challenges. This is obviously a different approach to the original architecture of Uniswap, so there's a lot of constraint for providing this. There's no guarantee of execution. Again, your execution based on how much you're willing to rebate or compensate the user, and there's always a gas limit at the block level that just no way to get around. So same vein, no guarantee of execution order. You cannot call swap or remove liquidity in before swap. This is to prevent attacks where you sandwich a user swap, or you remove liquidity to make the user have a worse slippage. You cannot add liquidity in before donate. This is to prevent stealing donation. You cannot change LP fee. This is not something talked about, but it's one of the Uniswap v4 features. But you cannot change that. And also the hooks cannot take assets from the. Again, this is Uniswap features that it's not being supported by the provider hook. Right. So one big challenge I'm not yet able to overcome is griefing attack. So in Uniswap v4, there's a concept called flash accounting. So that means you don't transfer any tokens. You just sort of keep track of everything that a user owes a pool or owned by a pool at a transient storage level, and that's get cleared out. That needs to be settled before the transaction finishes. But right now, the subscriber pool is able to change the non-delta balance, non-zero balance delta. But right now, there's really no way to prevent that. It would be a fairly minor additional feature from the core protocol to prevent this, and I'm talking to Uniswap, but at this point I don't think they're adding additional features, so there may be additional limitation just to get this working. Otherwise, this project is kind of finished. So starting next week, I'll probably start working on some Zindicator. This is more using, so it will be a suite of on-chain metrics and indicators for DeFi, mostly using Brevis ZK coprocessors. So right now, obviously the DeFi projects have some on-chain data, but never historical data. So using Brevis, I want to provide, these are just some of the example, probably what I'll start with is to provide on-chain verified ZK-proved historical volume, volatility, TVL, yield, etc. So yeah, that's it. Question? Okay. Any question? No?
So you say the project doesn't have to have ZK.
Okay.
I mean, it's okay that it's an Ethereum project, no? Because the Swap is part of the Ethereum ecosystem. So
I understand, but I still feel stupid.
No. And then Brevis is one of the sponsors. We should get you help if you want to connection.
Yeah. Sure. Yeah, let me try. I understand what Brevis can do at a high level, and I think this can be achieved. But let me get my hands dirty a little bit first before I talk to them with more specific questions. Yeah. All right. Cool. Thank you.
By the way, not a question, but just a finding coincidence. A friend of mine recently developed a project to like create Uniswap hook pools and sort of incentivize manners like staking, make some money from it.
Okay.
And I don't know if it's like related to your project.
Probably. Love to get in touch.
But if you just go to hookstore.xyz. Hookstore.xyz.
Okay.
Have a look. Like if it's similar to yours, then I can connect you both, and then you can solve some of the issues.
Awesome. Thank you.
Is it?
I came only to make sure that our slot is okay, so it's because we are still preparing. Is it okay?
So
11:55 as
45?
55 because
Please.
is everybody done?
Yeah.
So we're waiting
For the morning, yeah. Yeah, it's in.
He needs more time?
He needs a bit.